Okay, folks, let's begin this lecture where we are going to talk about streams. Take a look at streams like this one, this braided stream here, and talk about how that is related to the processes creating the stream, right? Gravity is pulling this water downhill and it's affecting the sediment load that's being transported along with it. It's being fed by various tributary streams, probably from upstream. And then this braided stream may well be a tributary of an even larger stream or river downstream of this one. So we'll talk about what this morphology means, what causes it, all sorts of things. First thing we're going to talk about is what streams are. In later sub-lectures, we'll get to what streams do, stream drainage patterns, and then finally discuss a little bit about flooding in streams. So when I say streams, what do I mean? Streams are any body of water, large or small, that flows over the land surface. So that would distinguish it like something like a lake that is sitting stationary, or it would distinguish it from the ocean. But in particular, when we talk about streams, we could be referring to a tiny little mountain stream like this one, or we could be referring to a big river like this one here. Rivers are just a subcategory of streams that are pretty big ones. So that's all we mean. Streams have various parts to them that we are going to want to know. So here we have a cross-sectional view of a stream and how it changes as you go from the headlands, the uplands up here in the mountains, and the streams that filter down slope, various tributaries all coming together here, meeting up, forming this meandering river that empties out into the ocean via a delta. We can talk about the gradient of the stream, and we'll get to that, where it begins much steeper, and then it gradually flattens out until it is nearly flat when it enters the ocean. So that gradient or slope will vary over the course of a stream as well. Streams have their own valleys, which are the areas over which the stream might migrate over time. So this here is the stream valley in this diagram down here. The stream has this particular course to it right now, but over time it actually might change and take a different course. And it might bow out in certain places. We actually see evidence of that in some of these Oxbow Lakes that we'll talk about. Streams also have a floodplain, which is the portion of the valley that is not filled by the current river channel. So the channel is where the water currently is. The floodplain is this flat area around the river where it can flood sometimes. So this that I'm coloring in is the floodplain. All this. Streams have tributaries. Those are streams that add water to the stream, but they're not the main one, right? So if rain falls on the uplands up here and it comes down this little valley, it's in this tiny little stream here, which is a tributary of the main stream. The main trunk of it is right there. And we can also talk about the uplands, which are places that are never flooded by, even in the course of high flood events, but they are drained and do drain into this particular stream. They might be higher hills or mountains or things like that. If we look at this cross-sectional view, just to get a sense of what this might look like, you can sometimes see ancient channels that have been buried by sediment that would be filled with somewhat coarser sediment like sand and gravel. And then the floodplain itself tends to be these layers of silt and clay, so finer sediments. The normal course of the river, it's moving relatively fast, so it can carry sand, some can even carry gravel. And then when it floods, the center of the river along its channel might still be running fast, but around the valley, it's going to slow down a lot, which is why it dumps silt and clay, and why you can end up with silt and clay in floodplain deposits. So we've talked a little bit about all these terms, talk about a few more. Sort of looking in finer detail, if you were looking at just a couple bends in the river, you're going to want to know what point bars are and cut banks. So many rivers can meander back and forth, as we've said, over time. And let's imagine this one is one that's flowing in, we'll say, this direction here. Don't see any great evidence looking at this, which way the river is flooding, but we'll say it's flowing this way. Over time, some areas of the river on the inside of the bend, so here's your bend, and this is the inside of the bend, are going to deposit sediment over time, and that is deposited on what is called a point bar. It's the inside of a bend, and it's where sediment accumulates during normal activity of the river. The cut bank is the area on the outside, and that is actually an area of erosion. So these rivers are simultaneously doing erosion and deposition. On the outside of the river, it's flowing the fastest, and it can actually eat into these walls here, into this cut bank, and erode some of that away over time. Terraces are ancient levels of the river. So at some point, there may have been sediment that filled all of this current area, and the river would have moved back and forth across this floodplain. The terraces are what remains of that old floodplain. So over time, the river here has dropped and left some of these terraces. Not all rivers have terraces, but the ones that have dropped over time may have terrace deposits you can find. These aren't the same as uplands, because uplands are never flooded by that river, whereas these terraces at least used to be traversed by this river. The terraces are these flat areas, right? They're floodplains. But where it had been eaten into at some point by cut banks and sort of eroded away, you have these steep escarpments that are the slopes that connect terraces to one another or connect the lowest terrace to the current floodplain. Those are escarpments. We'll talk about 4 different kinds of streams. Sometimes you only see 3 discussed. You'll always see braided and meandering discussed in these discussions. Straight streams are somewhat rare and really only happen when there's some other geologic factor that's causing them to be straight. But most of the time, the morphology, if you have some erosion and deposition both happening, is braided or meandering. Headwater streams are the furthest upland, the furthest toward the headwaters or toward the headlands. And those generally don't have much deposition going on. When you think of steep mountain streams, those are the headwater streams. So let's talk about them each individually. We'll start in the uplands. Headwater streams, also known as youthful or step pool streams. So if you go and you see in the mountains that there are often these pools that are linked by steps with little waterfalls, and then there's another pool, and then there's some more waterfalls, and then there's another pool. That's why it's called a step pool stream. That's just another name for these headwater streams. For the most part, these have more erosion going on than deposition, and they're actually cutting down into the land surface here. If you get enough area being drained by these, they might form these sort of V-shaped streams where the hillside here will slope gradually toward the stream, and then at the stream, it forms this notch, which is why it's a V, right? These are eroding mostly down instead of across the landscape. They're not moving back and forth like we've already seen those meandering streams do. These are also the most headward. They're the furthest upland. They're the closest to the mountains, and they're where the water starts. So there will be a lot of these headwater streams that feed most big streams, rivers, eventually. Braided streams are those streams which have multiple channels and often sandy, gravelly, especially sediment loads. In normal times, they have too little water to transport most of their load. So most of the time, they just can't move all this sediment that's in them because there's not enough water flowing down. These tend to be somewhat steeper than meandering, but they're not quite as steep as those upland streams. These are smaller than meandering river or meandering streams, and they will eventually probably feed into a meandering stream. So the main thing that causes these to be braided is that they have all the sediment and they generally have too little water to transport it. You don't see too many of these braided streams around, not in Tennessee, especially if you're staying in the valleys, because the valley, right, the Tennessee River Valley is mostly filled by the Tennessee River, and that has moved back and forth over time. That's a meandering stream. To give you an example, we might go somewhere like Alaska, where you can see more of these braided streams, and they have multiple channels. that are all flowing at once. It's not occupied by a single channel, and these channels can move back and forth across the landscape too. You can see all of this sediment. This is all sediment in here that the stream could carry if it had enough water to do so. This is still somewhat flat, right? It's not quite as flat as the river valleys of a meandering river, but it's also not nearly as steep as the headwater rivers that we were looking at before, headwater streams. Those headwater streams you might find running off of these if there's enough water coming down them. Meandering streams are so named because they meander. They wander back and forth across the landscape over time. So this would be time 1, and this would be time 2. And going from time 1 to time 2, you can tell that the course of the river has changed a little bit. They move side to side in this sort of snaking motion. And that's because the outside of each meander is where the water is moving fastest and where erosion can happen. So over time, we would erode some of that land away, and then we would erode a little bit more away until we get to what we see in time 2, where this meander is much more severe. At the same time, that inside at the point bar moves slower and deposits sediment. So here it's moving slower and it can drop some of its sediment. Might be sandy, might be gravelly. Go back here. So this area here is getting deposited on with some sand or some gravel. And so we build up these sandy, gravelly point bars that stick out. So we have cut bank and point bar. Just to remind you of those. We've seen those terms already. If we look at a cross section of the river here, the flow of the river is not just straight down it. It does spiral a little bit, and it does move faster on the outside. So here it's fast, and here it's relatively slow. And you can see the deposition of these layers of sediment over here on the point bar, looking at that. Whereas on this side, you don't see any deposition because what's going on is erosion at the cut bank. What happens after a really long time as these meander? So we had time 1 and time 2, and then we can look at time 3 and 4 down here. What would happen? Eventually, these meanders can grow close enough right here that an avulsion event, where the stream floods and escapes the channel, can cause the stream to cut off part of its own channel. That old segment that gets cut off then would sit as a lake on the surface. The water isn't flowing it anymore. We call those Oxbow Lakes. And they're a pretty sure sign when you see those in a river valley that you're dealing with a meandering river. So we can see that, for example, like at some point an avulsion event happens, this river floods and the channel starts to carve through here, and it makes enough of a new channel that this area is no longer carrying the water downstream. As a result, going from time 3 to time 4, we have a new cutoff and we form a new Oxbow Lake. Here we're using this stream channel demo to show you what one of these avulsion events might look like during a flood. You can see that most of the water is now going through the new cutoff. We'll skip ahead here a little bit and notice that once the flood is receded, this Oxbow Lake has been cut off from the new channel. Here's a picture of a real meandering river, and we can see a point bar here, and on the opposite bank would be a cut bank. Here's just another diagram of what that looks like over time, showing you where erosion is happening, where deposition is happening, where the point bar and cut bank are forming, and an example of a meander neck that's been cut off and formed a new Oxbow Lake. I like this picture showing Meandering River because you can see the difference in sediment load between this Oxbow Lake down here that's mostly clear to black because of organic matter being in there, but most of the sediment has settled out because the water isn't moving anymore. Whereas in the channel of the stream itself, it's still carrying lots of silt and clay that's making this a muddy brown color because the water still is moving. Remember that the size of sediment that can be moved is controlled by the energy of the moving medium, the speed of the moving medium in this case. I want to make a comment about the straight streams too, right? These are relatively uncommon. It's not common that you see a river or a stream that runs straight like this. And it generally only happens where the stream is confined. In this case, what's confining it? You can see all this really hard bedrock that has confined it to the straight pathway. It's very difficult for the river to do any sort of erosion on this, and it only does it very slowly, so it ends up sort of confined by this bedrock. When we talk about the stream profile, we're talking about how that slope changes from the start to the end of the stream. And this is a drawing of a typical stream profile where it starts steep and then gradually, very gradually shallows out over a certain distance. This could be hundreds to over 1,000 kilometers going from the source to the mouth of the river, the mouth being where that delta forms as it empties out into the ocean. So those rivers are steepest near the head and almost flat at the mouth. Those headwater streams are going to appear up here in the steepest part of the river. As those empty out, sometimes you'll have braided streams that you can see where it's still relatively steep, not quite as flat as it gets further down, but much less steep than it is in the headwaters. And then the meandering streams are what forms on the very flat surfaces nearest to the ocean. And you can see this river meandering right here, this diagram. One more thing that I want to point out is that some streams are intermittent. This is a category that can apply to other streams, implying that the stream is active for only part of the year, only when the water table, that is the level of groundwater, is high enough. We will talk a little bit more about groundwater later in the course, but the general idea is that underground, you're going to eventually hit something called a water table, which is where all of the pores are now saturated with water. Water percolates downward and fills up those underground aquifers, some of which are unconfined. At any rate, the surface of the water of these streams is usually coincident with the level of groundwater around in the general area. So this height is where the groundwater currently is, a foot or two below the surface of the ground in all these places. In an intermittent stream, sometimes the groundwater drops so low that the stream channel here is no longer filled with water. And that's what an intermittent stream is, when the water level drops below the surface of the channel.